Hello friends, welcome to IOQM lecture series. So we will be starting with number theory part 11. So let us continue. The positive integer a, b, a minus b and a plus b are all prime numbers. Then the sum of these four primes is. So we have four positive integers a, b, a minus b and a plus b. So if a minus b is positive integer, then what can we say? We can say कि a is greater than b. Okay. So we have this. So let's see. If a minus b and a plus b are all primes, let's play with parity. Whenever we have a minus b, a plus b, we will play with parity. So odd plus minus odd is what? Even. Even plus minus even is what? Again even. But odd plus minus even is what? It is odd. And a prime number, if we have a minus b, a plus b, there is only one prime number which is even, which is 2. Other than that, all prime numbers are odd. Correct. So to get odd prime numbers, we need a one odd prime number and one even prime number. And we have only one even prime number. So that prime number is 2. Okay. So if we assume, so which is smaller? 2 is the smallest prime number. 2 is smallest prime number. Okay. So now if we want to give 2 to a or b, which one can we give? Yes, we can give it to b. So b is 2. Now a, 2, a minus 2 and a plus 2 all are prime numbers. Okay. So they have asked the sum of these four primes is. So sum of these four prime numbers is how much? 3a plus 2. Okay. So the sum is 3a plus 2. Okay. Now we have to find one more. So let's write down all the prime numbers. Let's say 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Okay. So these prime numbers, what is the difference between them? The difference is 4. So let's see what whose difference is 4. This difference is 4. Then this difference is 4. Then what all is there? 59, no, 57, no, 47. This difference is 4. This is 4. Okay. So if we have 13 and 17 is a minus 2 and a plus 2. What is a? A is 11. Okay. It is a prime. This here a is 39. It is not a prime. 41. Here it will be, sorry, 45. Not a prime. Here it will be 81. Not a prime. So one option we have is a is 11. Correct. So we can say 11 2. 11 minus 2 is sorry, here a is 15. Okay, so that is also not a prime. Yeah, then so there might be. Okay, now let's check. We know one of the numbers is 2, that is for sure. So we have a, 2, a minus 2 and a plus 2. Now we have to check whether 3a plus 2 is whether it is even or divisible by 3, 5, 7 or prime. Divisible by 3 or 5 or 7 or prime. Okay. So first let's check for even. A is odd. Why? Because A is a odd prime number. So 3 into odd. Odd into odd is what? Odd. So odd plus even will give you odd. So 3 plus A is not a even number. Then 3A plus 2. 3A plus 2. 3 does 3 divide 3A plus 2? No, 3A does not 3 does not divide 3A plus 2. Why? Because then 3 would have to divide 2. So 3 is also out of option. Now let's check for 5. Okay. So any odd number, we can say, or any prime number. Prime is congruent to what all? Mod 5, that we have to see. So let's just check. 7 is what? 2. Then 11 is 1. 13 is again 2. 17 is 2. 19 is minus 1. This is 3. This is minus 1. So what have we got? We have got 2, we have got 4, we have got 1, we have got 3. 1, 2, 3, 4. Yeah. So basically we have got all. So A can be congruent to 0 or 1 or 2 or 0. It can't be 1, 2, 3, 4. We got 0, only one prime number which it is there, which is 5. And we cannot take A as 5 because it would be 5, 2. Then 5 minus 2 is 3 and 5 plus 2 is 7. Oh, actually, we can take A as 5. If A is 5, then what is 3A? 15. 15 plus 2, which it is 17, and 17 is a prime number itself. So what answer do we have? The answer is 5. So 7 and 11, this also, how did we, okay, so 3 and 7, what pair did we get for A minus 2 and A plus 2? 3 and 7, there is a difference of 4, middle number is 5, so minus 2 plus 2. Okay, so next, it is 17 and 17 is a prime. Now let us move on to the next question. For how many integers n is n upon 20 minus n is square of an integer. So let us take ki n upon 20 minus n is square of x. So this is equal to x square. Correct. So if we do n is equal to x square 20 minus n, then n is equal to 20x square minus x square n. So x n into x square plus 1 is equal to 20x square. So n is equal to what? 20x square upon x square plus 1. Okay. 20 minus n, 20x square, the n we take common, x square plus 1 we get, yes. So we have n as 20 x square upon x square plus 1. Okay. Now, for x square plus 1 will not divide x square for all x. For any x you take in integers, x square plus 1 won't divide x square. Why? Because a larger number cannot divide a smaller number, and x square is always a positive. So x square plus 1 is always bigger than x square. Okay, we have this. Now, if n is integer, then what do we have? We have x square plus 1 divides 20x square, and x square plus 1 does not divide x square, we have from this. So x square plus 1 will divide what? It will divide 20. It has to divide 20. So now 20. What are the factors of 20? Let's see. Factors of 20 are what? 1. Okay. Then 2. We have 4. We have 5. We have 10. And then directly 20. So x square plus 1 can be any of these. So x square plus 1 is equal to 1, x is equal to 0. X square plus 1 is equal to 2, x is equal to 1. Then x square plus 1 is equal to 4, x is equal to root 3, which is not a square. Then x square is equal to 5, x square plus 1 is equal to 5, x is equal to 2. X square plus 1 is equal to 10, x is equal to 3. And x square plus 1 is equal to 20, x is equal to root 19, which is again not a square. So what all integer value we got? So 0, then 1, then 2 and 3. So 0, 1, 2, 3. It is x. When x is this, when x is 0, 1, 2, 3, what is the value of n? Let's see. When n is equal to 0, x is equal to 0. When x is equal to 1, n is equal to what? Let's put in this formula. So 20 upon 2, n is 10. X is equal to 2, n is equal to 20 into 4 upon okay. When did we get x square plus 1? Okay. So we have 20 into 4 upon 5. So 5 for the n is equal to 16. Then x is equal to 3. We have n is equal to 20 into 9 by 10. So 18. So what all values of n are there? How many integers? 4 integers. So our answer is 4. When n is equal to 0, 10, 16, 18, that time it is square of an integer. Okay. So what did we do here exactly? We found one condition ki this is some integer square, but finding some integer square is tough. So what we did, we converted it into this form. So we know ki this fraction is a integer. Now finding integer is always easier than finding an integer square. So we try to find for what all values of x this is an integer. Okay. So now let's move on to the next question. For how many positive integers n is n square minus 3n plus 2 a prime number? Okay. So n square minus 3n plus 2, we have to say for how many values it is a prime number. Okay. So what is the basic condition? Basic condition for any number. For any number, let's say n, to be prime. The condition is factors of n can be only 1 and n itself, the 1 and the number itself. Okay, these are the factors. So now let's find factors of this number, n square minus 3n plus 2, this. So can we factorize this? Plus 2, so minus 2 minus 1. So this we can write as minus 2 minus 1. So n square and here, so n square minus 2n minus n plus 2 is equal to 0. So n into n minus 2 minus n into minus of n minus 2 is equal to 0. So n minus 1 So how we got this? N minus 2 taking common, from here n, from here minus 1 is equal to 0. So n is equal to 2 or n is equal to 1. For this it is 0. So basically we don't have to factor like make it equal to 0, it is equal to this. So n minus 2 divides n square minus 3n plus 2, and n minus 1 also divides n square minus 3n plus 2, and 1 obviously divides n square minus 3n plus 2. Okay. So one of them, if we make one, n minus 1 is equal to 1 or n minus 2 is equal to 1. If we make one of them equal to 1, then our then let's see what we get. N is equal to 2. So n is equal to 2 we get. So this thing becomes 0, and 0 is not a prime number, so no. And if we make n is equal to 3, if we make n is equal to 3, then what will we get? If n is 3, then n minus 2 will become 1, n minus 1 will become 2. So only factors are 1 and 2. So this thing will become 2, and 2 is a prime number. If now n is greater than if n is greater than 3, what will happen? N minus 2 will be some number, let's say m. N minus 1 will be another number different, which is m minus 1. M plus 1. So how many factors are there that we know? 1, m and m plus 1. These are all different factors. So it is not a prime number. So for how many integers n? So for only one integer, that is n is equal to 3, this is a prime number. So for how many integers? For only one integer. One integer. Okay. So let's move on to the next question. Given that this, okay, so what have they given? 3 factorial ka factorial and factorial of this upon 3 factorial. This is equal to what? K into n factorial, and we have to find k and n such that and n is as large as possible. Okay, we have to find n which is as large as possible. So let's simplify this. So first let's simplify 3 factorial. So 3 factorial is equal to what? 1 into 2 into 3, which is nothing but 6. So this thing gets converted to 6 factorial ka factorial upon 320 upon 3 factorial, which is equal to what? Now 6 factorial. 6 factorial is equal to 6 into 5 into 4 into 3 factorial, which is nothing but 6 into 5 into 4 into again 6, which is 36 into 20, which is 720. So it is 720 factorial divided by 3 factorial. Okay, so I can now write 720 factorial divided by 6. Correct. So now to remove this, I can write 720 factorial as 720 into 719 factorial by 6. So 6 ones are 6, 6 2s are 12. So this is 120. So it became now 120 into 719 factorial. Now can we find a number n which is larger than 719 and we will still get a factorial? No. Why? Because if we take it as 6 factorial ka factorial, this is the reduced form. You take anything 720 into 719, if you remove one more number, this will become 718 factorial. If you remove one more number, this will become 717 factorial. So it will only reduce, it won't increase. So what is the maximum or largest n possible? Largest n possible is 719. So in this case, what is our k? K is 120 and n is 719. So what they want? They want k plus n. So k plus n will equal to 889. So what is our final answer? Our final answer will be 889. Okay. So that's it for this lecture. We will continue with few more examples in the next class. So till then, thank you.